Okay, so hello and welcome back. So in this video we want to continue with basically what we were doing was basically the different types of probability of basically the axiomatic approach to probability, of course. And we have an example over here, which is example number 12. The question is that two students, Anil and Ashima, appeared in an examination. These two basically appeared in an examination. So the experiment, you could say that basically two students appeared in an examination. And probably you could think that, for example, the different outcomes of this experiment would be different scores of these two students in the examination, meaning that you would get, for example, a bunch of numbers, like, for example, you would get probably a bunch of numbers like, for example, I don't know, 55, 65, and then well, of course, basically the first student, for example, if I assume that you could score anywhere between, for example, 1% and for example 100% on a typical examination, so that the first person could go anywhere between 1% and 100%. And so the second student could do the same thing. He or she could go from 1% to all the way up to 100%. Now you would get all of these ordered pairs of, for example, 1% with 1%, 1% with 2%, and so on and so forth. So you would have basically 100 numbers over here. You would have 100 outcomes over here, and 100 times 100 would be 10,000 different ordered pairs, each basically containing, for example, you would get an S, like, for example, the ordered pairs X and Y, in such a way that basically X is the first student's score, and Y is the second student's score. And then you would get a bunch of numbers like, for example, 20%. The second student could be, for example, could go to 50%. Of course, the percent sign, I'm not using it here, so you could get 2050, you could get 2151, you could get, for example, 25, for example, come up, I don't know, 75, and so on and so forth, 10,000 times. Right? That would be your sample space. Now, none of this has been given us to this problem, has been given us in this problem, or has been given to us in this problem. All that has been given to us is that basically Anil and Ashima, and I'm taking that Anil is a boy and Ashima is a girl. So Anil and Ashima have taken part in this examination, and then Anil and then basically I know that the probability of Anil passing the test is 5%, or 0.05, and the probability of Ashima passing the test is 0.10, which is 10%. So so that means that Anil has half the chance of passing the test compared to Ashima. And the probability that both will pass the test is 0.02. Okay? And you want to And now based on this information, you want to answer these 3 questions. So that the questions are, what is the probability that both Anil and Ashima will not pass the test? What is the probability that at least one of them will not pass the test? And what is the probability that only one of them will pass the test? And so these are pretty confusing statements. If you actually want to solve this problem, you might actually, I don't know if you would, but you might get into a lot of logical problems. And in such cases, you need to have you need to have some sort of specific strategy in order to solve the problem and learn from it. Otherwise, you will get stuck. Okay? Meaning that, for example, in this case, there are many different ways to think about this problem. For example, when you use the word both, I could think of, for example, when the word both is used, I could say that I could, for example, logically think that now here I need to use, for example, the concept of union, or I could use the concept of and both of them would probably logically be correct. But of course only one of them is correct. And that's the good thing about mathematics. You don't have different choices. You don't have many right answers, or in some cases you have many different ways to solve a problem. But when it comes to such concepts, for example, using using intersection, or using basically union, or any one of these, there is always only one of them correct. You cannot use them interchangeably. Otherwise, your results will be simply wrong. Okay? Now, in some cases, it's not possible really to know what to do. For example, even if you understand all the concepts pretty well, and even if you understand all the concepts related to this question, for example, completely well, sometimes there is no way to know what to do. So in such cases, what you do is a strategy that I have made up, okay? And that's the only thing that usually works. So what you want to do here is that you take a look at the solution, okay? And then based on how the problem has been solved, okay, you need to pay attention to how I'm phrasing this. You need to take a look at the solution. For example, in the case of, for example, the first part of this question, which is A3, this event, both Anil and Ashima will not pass the test. So, for example, here I would say that when I say both of them will not pass the test, so there is many different ways that I can think about this. So I could say that, for example, I will take this statement as, for example, both basically Anil and, for example, Ashima will pass the test. And then I call it, for example, some event like, for example, B1. I call it some event like E1. Calculate the possibility of this, calculate the probability of this, and then based on that, calculate the probability of not B1. And then I'm basically in this train of thought, I'm assuming that, for example, when I use a not over here, then this event A3 is I can think of the event A3 as not B1 if B1 is basically this statement. Okay. And well, there are many other different ways that I can think about this, meaning that, for example, I could say that, well, I have to basically go in and negate this statement and say that, for example, when I say both Anil and Ashima will not pass the test, this statement means that none of them will pass the test, and so that means that when I say none of them, then that means that Anil doesn't pass the test and Ashima doesn't pass the test, and so then put those two statements together using an and, for example, using the connective and, well, in the same way you will get many different ways to think about this problem. But the way that you think about the problem, it has to be logically right, and it has to be basically the right mathematical logic, not just the ordinary logic that we use probably on a day-to-day basis in our daily lives, because that logic is different. People use logic in any way that they want. As long as it serves them, they use logic in any different way that serves them. So that's not basically a measure of whether basically their logic is right or wrong. That way you cannot decide it. The only way that you can decide it, that you can decide whether your logic is right or not in mathematics, is that if the kind of logic that you use for solving a problem gets you to the right answer, and not just in one case, but in many different cases, the kind of logic and reasoning that you use gets you to the right answer. If that's the case, then that means that your logic is right. Otherwise, there is something wrong with your logic, or some part of it, or some link in your reasoning is probably flawed, okay? Or definitely flawed, of course, if you don't get to the right answer. So now in order to get to, now, assuming that there is no one to teach you how to solve a typical problem, for example, like this, the way that you can teach yourself how to think about a typical problem like this, what you can do is that, first of all, you put all of your assumptions aside. That, for example, I need to think about this problem in this way or that way, or this is correct or that is correct, and so on and so forth. Put all of your assumptions aside. You take a look at the solution and the way that the problem has been solved, and you need to take it, you need to look and see what sort of typical, how the problem has been solved, using which concepts, for example, using which connective, and exactly how. And once you've seen that, then you need to kind of put together the kind of logic and reasoning that goes with the way that the problem has been solved in the solution, right? Now you have the kind of reasoning that you think is right for solving, for example, this typical problem. But there is still a problem, and the problem is that, well, you have seen the solution. Based on that solution, you have put together some sort of reasoning and logic and some train of thought, and you've used that train of thought in order to basically reason your way through and get to the answer, right? Now, what you need to do is that you need to test this train of thought and test this reasoning in the case of at least 3-4 more problems, 3-4 more similar problems. If it works in the case of at least 3-4 more problems, then there is 99.99% chance that your reasoning is not flawed. You can use it for any basically similar typical situation that comes your way in the future. Otherwise, you have to discard it, because if, for example, if you use that line of reasoning in somewhere and it gives you the wrong answer, then that means that either you're not supposed to use that train of thought in that situation, or basically your reasoning is wrong in the first place. So then you have to discard it. But then that's another problem, and that's up to you to decide whether which one is actually the case. So that's basically how you teach yourself how to solve a problem if you don't know how to solve it, but if you have the solution. And the solution, and what I mean by that when I say you have the solution, so the solution that I have here is that, for example, the solution that I have here is that I'll write down the exact solution that has been provided in the book. It says that, for example, to solve this first part, both Anil and Ashima will not pass the test. So what they have provided as the solution is that the event both Anil and Ashima will not qualify the examination may be expressed as E prime intersection with F prime. So this is crucially important. Now you know that, for example, this if I call this, for example, now let me actually call these the exact same way that they have called them, so that we may basically use their solution. So for example, and of course I have to change these as well. So for example, I call this basically event E, and I call this event F, right? And now if that is the case, then P of, for example, P of E is equal to 0.05 and P of F is equal to 0.10, and I'm going to just forget about this right now, right? So now the solution tells me that the event both Anil and Ashima will not pass the test or will not qualify the examination, may be expressed as E prime intersection with F prime. Based on E and F, I can write this as E prime intersection with F prime, right? So that this event might be expressed as E prime intersection with F prime. So now I know how I'm supposed to write, how I'm supposed to basically think of this statement in terms of, for example, E and F. So anything might have been possible. For example, based on my own logic, I would have said that, I would have thought to myself that, for example, okay, so I'm going to use and here, or I'm going to use the union here, or I'm going to use this or that. But now I know that I'm supposed to use the concept of intersection and the complement of those two events. So now what I can do is that I can go back and somehow find some sort of logical explanation for this part of the problem, that for this part of the solution, that, for example, this event based on these two events can be written as, for example, this thing over here, right? So that's basically what I mean by that. And we will do that step by step until we get to the whole solution. Okay, so what that means now is that to find some way to explain this step is that, of course, when basically you could say that the word both here is connected with the intersection part. And what that means is that, for example, let's say that you have two events. Let's say that you have two events, for example, let's say that you throw a dice, right? You throw a dice and your sample space would be, for example, 1, 2, 3, 4, 5, and 6. Now based on this experiment, let's basically define two different events. For example, event A, I defined the event as, for example, 1, 2, 3, and 4, right? 1, 2, 3, and 4. Event B, I define it as, for example, 4, 5, and 6. Now you can see that basically A intersection B is equal to this set which has only one member 4, which means that if this outcome occurs as a result of basically doing this experiment of throwing the dice, meaning that if you throw the dice and then you get a 4, both of these events, you can say that both of these events have occurred. And so probably unconsciously, I already used the word both in the sentence that I just said. I said that when the outcome 4 basically occurs as a result of doing this experiment, then you can say that both event A and event B will occur. And then, of course, in order to check which outcomes will basically lead us to the occurrence of both of the events together, you have to take the intersection of the two sets, and then you will know what those outcomes are. So then when you say that, for example, both Anil and Ashima will basically not pass the test. Now the not is a different story. So then, but basically for the both part, you can use the intersection concept, the concept of intersection. Now we are saying that both Anil and Ashima will not pass the test. I could break this down as basically, I could break this statement down as Anil basically will not pass the test, and also Ashima will not pass the test. And also Ashima will not pass the test. So, but over here Anil will pass the test is event E, and Ashima will pass the test is event F. Now, if this is event E and this is event F, you can imagine that in your set of basically in your sample space, let's suppose that this is the sample space related to this experiment. Now, in your sample space, there might be, I don't know, the sample space has not been given here and there is no way to assume anything because, well, you simply just don't know, right? But you could imagine that in your sample space there are a number of outcomes that will result in occurring event E, meaning that now since I have to find some way to think about this, I can make an assumption that the sample space of this experiment is, for example, something like, for example, 1, 2, for example, 25, 75, and for example, I don't know, 55, 75, and these ordered pairs basically, let's suppose that, for example, the first number is related to anil and the second number is related to a schema, right? That's how you could think about this. Of course, there are other ways as well, probably, but that's one way that you can think about this. Now, if basically there are basically some outcomes here in this sample space that will result in anil passing the test, right? So anil passing the test, that would be event E. So that means that those events would be, I could put it in a set and put all of those events over here that basically result in event E occurring, and then I can call that, for example, set E or event E. Now all the other members of S that you cannot find in E, of course you can call them E prime. So again, I repeat this, all the other members of S that you cannot find in E, you can call them E prime. And of course, since the set E is the set of all the ordered pairs that will result in event E occurring, then that means that all the members of event E prime, all the members of this set or event E prime will actually result in event E not occurring, right? So what that means is that then when I say that anil will not pass the test, so of course in that case you can simply use the concept of E prime or the concept of complement in the case of this situation over here. And of course again we are saying that the schema will not pass the test either, so then in that case again using the same logic you can find F prime. And well, we have also justified the concept of intersection here as well, so we are good to go. We have no problem with this. But now you need to do one important thing. You need to learn from the way that you basically logically explain this thing to yourself. And then again, as I mentioned before, use the same logic for the kind of problem that you think the same kind of logic can be applied to, and see if basically your logic works at least in the case of, for example, 4 or 5 similar problems. If that's the case, then you have no problem. That means that your logic is not flawed. Otherwise, there is something wrong with your logic, and that you will have to find out with, again, other thought experiments, or basically logic train experiments or something like that. These kinds of things you will basically learn over time, right? So that's basically for the first part. We are good to go. Now let's get to the next parts of this problem. Okay, so now here we said that basically we could, so the event that basically both anil and the schema will not pass the test, will not qualify the examination, may be expressed as E prime intersection F prime. Now, of course you know that basically E prime is the same thing as not E, is the same thing as not E, which means that basically anil will not qualify the examination. Not E would be basically based on this event, you would write not E as Anil will not pass the exam, will not pass the test. Will not pass the test. And of course this not doesn't have necessarily anything directly with this not over here. It's based on what happens in the set. You know, we said that basically you have some, for example, you have some sample space over here related to some experiment, and you have some event A related to the same experiment. Now some outcomes that you have in your sample set, you can find them in this set A, right? So, and of course there is some other basically outcomes in the sample set that you cannot find in A. So those members of the sample set that you cannot find in A, you can call it B, for example. You can call it B, and then of course you know that the union of A and B is equal to S if you basically include all of the members of S in both of in these two sets, meaning that some members, and let's suppose that for example A intersection B is equal to the null set, meaning that these two have nothing in common. So you have taken some members of your S and put them in A, and the rest of those members you have put them in B, right? And these two have nothing in common, meaning that you have not repeated anything or anything like that. So then in this case, or in this situation, this B, you can call it A prime. So that means that A prime is nothing but all the members of S that cannot be found in A. That is A prime. And of course, if I take, for example, A as the event that Anil will pass the test, and these are all the outcomes that will favor that event, then of course all of these favors will not basically favor event A, otherwise they would be a part of this set, right? So then what that means is that then I can call them A prime. So that means that A prime simply means that Anil will not pass the test, because these outcomes will not favor basically A, and A is the event that Anil will pass the test. So basically if that doesn't happen, that means that Anil will not pass the test. So that's based on this that we are writing Anil will not pass the test here. Otherwise you wouldn't necessarily just write, whenever you see a not over here, then maybe you could, I don't know really, but the reason is basically this, not that you just, wherever you just see a not over here, then you put the not exactly in your sentence, that in your sentence describing the event. That doesn't necessarily, most probably never work like that, unless that's the case, which I'm not really sure about, you know. But anyway, so here we said that basically, since basically E prime is not E, of course, which that is basically Anil will not qualify the examination or will not pass the test, and F prime is not F, and F prime is the same thing as not F, meaning that a Sheila will not, by the same logic, will not pass the test, and also there is something in the algebra of sets, or the set theory, which is called De Morgan's law. So De Morgan's law is basically when you have E prime, for example, E prime intersection with F prime, that is based on everything that happens over there, and we cannot really right now go back over there. But long story short, this is called De Morgan's law, and that is equal to E union F, basically whole prime, right? So E prime intersection with F prime is always equal to E union F whole prime. That is called De Morgan's law. De Morgan's law. So now, since that is the case, then since I want to calculate basically this thing over here, I want to calculate the probability of this thing over here. So I can write the probability E prime intersection F prime is the same thing as the probability is the same thing as probability of E union F whole prime. Now, of course, you know that P of E union F based on what we said before in the previous video probably, is basically P of F plus P of E plus P of F minus P of E intersection F, right? So that means that P of E union F is equal to P of E, which is basically we have the value over here 0.05, and P of F is 0.10, and this one is by the way also P of E intersection F. This is P of E intersection F, and the reason for that I will talk about this in just a few moments. But but now to put these values in that formula, I have P of E as 0.05 plus 0.1 minus 0.02, if I'm not mistaken. And so that is equal to, this is 0.15 minus 0.02, which is equal to 0.13. Is equal to 0.13. That means that P of E union F is equal to 0.13. And then based on that, of course, you can calculate P of E union F whole prime, because you know that P of A plus okay, so then basically we wanted to calculate the probability of E union F whole prime, and then you know that of course P of A plus P of A prime is equal to 1. So based on this, you can write basically P of E union F plus P of basically P of E union F whole prime is equal to 1, which means that then 0.13 plus P of E union F whole prime is equal to 1, which means that P of E union F whole prime is equal to 1 minus 0.13, which is the same thing as 0.87. So that means that so this is basically the probability of basically that this thing over here, that both Anil and the Shima will not pass the test. The probability that both Anil and Ashima will not pass the test, right? So that's one part of the question, and as you can see that it basically typically takes a long time to learn how to solve such typical problems. But when you understand this, the procedure, then you have essentially understood many. I mean, then you have essentially understood how to basically use many different concepts that you have learned before in conjunction with one another to learn to basically to solve a problem which is probably much more complex than the kind of problems that you had solved that you have solved before. So now the next part of this question is at least one of them will not qualify the examination. So the next part is at least one of them will not pass the test. So the next part is at least the probability that you want to find the probability of this event happening, and the event is at least one of them will not pass the test. Will not pass the test. So if at least one of them will not pass the test, so now you need to somehow again write this event in terms of these two events that we have up here, which is basically E and F. E is Anil will pass the test, and F is Ashima will pass the test. And then over here we have at least one of them will not pass the test, meaning that now basically the right way to think about this so if I call this event, for example, call it for example A1, right? If I call this event A1, now basically I can write this expression as P of A1, meaning the probability that the probability of this event happening is the same thing as the probability of, and let me actually write another experiment, another basically expression over here as well. Based on this event, I can basically define another event which is both of them will qualify. Both of them will pass the test. Will pass the test. So what that means is that again, if you want to, I suppose the only way that you can that we have in order to be able to get from such events to such an event, and then meaning that basically these two A1 and A2, I need to tell you that A1 and A2 are complementary events. Are complementary events. Now let's see what complementary events are, because I need to basically go back to the definition of complementary events. I don't know where they were. So we said that we need to basically go back and do a little bit of definition here. So basically about complementary events, what we said was that for every event A, there corresponds another event A prime. There corresponds another event A prime called the complementary event to A. Called the complementary event to A, right? It is also called the event not A, also called the event not A, right? Not A. Now, for example, take the experiment of tossing 3 coins. So the experiment of tossing 3 coins, right? In the experiment of tossing 3 coins, you would get a sample space that has 8 outcomes. You get, for example, HHH, you get HHT, you get HTH, you get THH, you get HTT, you get THT, you get TTH, you get TTT. Now let A be the event, let A be, which is equal to basically HTH, HTH, HHT, HHT, and THH, and THH be the event only one tail appears. Be the event only, well, one tail appears. One tails appears. Right? Only one tails appears. Now clearly for the outcome HTT, which is this event, this outcome here, the event A has not occurred, because here you have basically 2 tails. So for this outcome, this event A has not occurred. But we may say that the event not A has occurred. So basically, for example, for outcome, for example, HTT, the event A has not occurred. But for the same for the same basically outcome, you can say that the event not A has occurred. Okay, you can say that the event not A has occurred. Thus, with every outcome which is not in A, we say that not A has occurred. Thus, with every outcome which is not in A, with every outcome which is not in A, we say that not A occurs. We say that not A, which is an event in and of itself, occurs. Okay? So, thus the complementary event not A to the event A is, thus the complementary event not A to the event A is basically A prime, which is all the outcomes that you cannot find in A. And that in turn means that the two of course we will talk about them, but let's first write this down. So for example, HTH is already, delete this, erase this. So HTH is here, HHT is here, THH is here, and except for these, the rest of these outcomes belong to A prime, which is HHH and HTT and THT and TTH and TTT and TTT. So you have 1, 2, 3, 4, 5 basically outcomes here. Or you can say that A prime is basically omega, such that omega belongs to S, and omega does not belong to A. That you can say as well, which is of course the same thing as S minus A, So that's basically the two complementary events, A and A prime. Now of course you can say that these two events are the two complementary events A and A prime are mutually exclusive, because there is no way that there is any outcome that ensures the occurrence of these two events simultaneously. So you can say that it follows that basically A and A prime are mutually exclusive, and also exhaustive. Meaning that when you say mutually exclusive, what that means is that when you write A intersection with A prime, that is equal to the null set. There is no member that they have in common or they share commonly. And when you say that they are exhaustive, that means that A union with A prime is equal to S. That is always the case. So that means that you can say that two complementary events, A and A prime, are always mutually exclusive and exhaustive based on the definition of complementary events. Now let's go back over here and see how we can solve this problem, the rest of this problem actually. Okay, so now let me take a few minutes rest. I'll be back, and we will continue with the second part of this question. Okay, so now basically based on the concept of complementary events, let's go and solve the second part of this problem. So basically we said that at least one of them will not pass the test, right? So if you say that at least one of them will not pass the test, that means that basically there is at least one outcome. That means that there is at least one outcome in S that will result in in basically one of the students not passing the test. And so the logical opposite of that would be both of them will pass the test, right? So that means that basically then, of course, A1 and A2 are complementary events, meaning that at least one of them will not pass the test. That means that basically at least there is basically one event, or there is one outcome that will favor this event, and then complementary to that would be another event, meaning that then the rest of the students will pass the test, which in this case is basically just one other student, meaning that then one of them is passing the test, the other one is not passing the test. So and the opposite of that situation would be and basically complementary to that would be basically both of them will pass the test, meaning that there is no event that will result in any one of them not passing the test, right? So now, since A1 and A2 are complementary events, what I can do is that basically I can write what I wanted to find out was basically the probability of at least one of them will not qualify the examination, or at least one of them will not pass the test. That's what I wanted to find the probability of. Now, since you know that basically if A and A prime are basically complementary events, then of course there is this relationship between A and A prime, P of A prime plus P of A is equal to 1. And so based on this you can write basically P of A1 plus P of A2 is equal to 1. Now P of A1 is what I want to calculate, so I just write it as P of A1. Now P of A2 is the probability that both of them will pass the test. And over here we had the probability that both will pass the test was 0.02, and that is equal to 1. So that means that P of A1 is equal to 1 minus 0.02, which is equal to 0.98. And that is the probability that at least one of them will not pass the test. Will not pass the test. So that is that. Now there is also another event here, and there is something, and I need to warn you here, give you a little bit of a warning, and that is if you happen to make mistakes using, basically while you're solving such exercises and such problems, you cannot be discouraged or you cannot be disappointed, because these are tricky concepts, and since it comes to logic, in logic you can always make, since the concept is a little bit tricky, you can always make mistakes. So you just need to be patient with yourself and take your time. If you cannot solve the problem, take a look at the solution, and of course learn from the solution and learn from the mistakes that you made. Otherwise, there is no point in getting disappointed or discouraged. That just doesn't make any sense, because there is always one more time that you can try and solve the problem, keep going, and that's basically what you can always do. So now the third part of this question we will take care of in the next video. See you in the next video.